Now we will see in three-dimensional geometry how to find the equation of the line in space. So it can be done in two ways. So you will get the problems where you have to find the equations when it passes through a given point and the direction will be given. So either the line will be parallel to some line, some other line, or perpendicular to some line. So that will be given to you. And here the second case, when it passes through the 2 points. So first we will discuss the first point, that is equation of the line passing through a given point and parallel to some other point. So now we'll discuss the first case, when the equation of the line passes through a point and is parallel to the given vector. So let's say a line is passing through A, and line passes through A and is parallel to another vector B. So in this case the line will be given as, so here we will write R equals to A, vector A plus lambda. Lambda is a constant into vector B. So that is the equation of the line when it is passing through a vector A and parallel to the vector B. So this will be the equation, and this is also known as the vector form of the equation. So that is the vector form. Now we'll find out the other form of the equation, that is the Cartesian form. So for the Cartesian form, let's say our x is xi plus yj plus zk, and a is xi plus y1j plus z1k, and b is another vector that is given as a, I, bj and ck. So you can write this vector equation in this form. So we can write this equation in this form. So here xi plus yj plus zk is equals to x1i plus yj plus z1k plus lambda ai plus bj plus ck that we have here. So what we'll do here, we'll just write x minus x1i, we can write it like this, plus y minus y1j plus z minus z1k can be written as equals to lambda into ai plus bj plus ck. And then you can compare, when you will compare the I coefficient and jj coefficient and kk coefficient, so you will find this thing, x minus x1 will be same as lambda a. So from here you get x minus x1 will be x minus x1 divided by a will be same as lambda, and if you compare the thing with y and j coefficient, so you will get y minus y1 by b. Same way you will get z minus z1 divided by c. So all this will be same as equals to lambda. So here all these ratios are equal, so we can write it as x minus x1 by a equals to y minus y1 b equals to z minus z1 c. So only this thing is this form is known as the Cartesian form. As you can see in this form, you are not getting the ijk or the unit vectors along x, y, z axis. So this you will get in the numeric form only. So this is known as the Cartesian form. Only variables you will get, that will be x, y, and z. So here this coordinate, this x1, y1, z1 is coming from the point. So x minus the coordinate that you will get from the a from which it is passing, x1, divide by a you will get from the vector which is parallel, the vector which is parallel to the line, required line. So you will get a from there, and then y minus y1 you get from the point that is given, and b you will get from the parallel line. So like this you can get the Cartesian form. So that is very important. Sometimes you'll get 1 mark question to just convert the vector form in the Cartesian form, or either the Cartesian form into the vector form. This is very, very important. Now let's make it more clear with examples. So we have a question, find the equation of the line passing through the point 1, 2, 3. So here your a will be, the passing point a will be I plus 2j plus 3k. This will give your A, and this is parallel to this, so this will give you B. So B is already given, so that is 3i plus 2j plus 2k. So here we have to find out the equation. Now I'll just tell you how to find out the vector and the Cartesian form as well. So R will be same as, you know that R is A plus lambda B. So I just simply put the value. So I plus 2j plus 3k plus lambda into 3i plus 2j minus 2k. So that is the vector form. Everything is in the vector form. So that is the vector form. Now I'll show you how to find out the Cartesian form. So this form is vector form. Now the Cartesian form, you know, it is x minus x1 divided by A equals to y minus y1 divided by B equals to z minus z1 divided by C. So you can write it directly also. So here we have x1. From where you will get the x1? This is your x1, y1 or z1. So from here you will get your x1, y1, z1, and ABC. From where you will get A will be this coefficient of A, coefficient of J will be B, and coefficient of K will be C. So you can just simply write these values and you'll get the answer. So here x minus A, I've told you that will get from here. So that is 1 divided by A is 3, and then y minus 2 divided by 2 equals to z minus 3 divided by minus 2. So that is the Cartesian form. And if you get the vector form, so simply vector to Cartesian you can convert. So you just have to see, here we have the R. So R will give you only x, I, y, j plus zk. So x minus 1 divided by 3, then y minus 2 divided by 2, z minus 3 divided by minus 2 will give you the same equation. So like this you can get in the exam as well. And when you will get the Cartesian form and you have to convert it in the vector form, so simply you can get, first you can x, y, z, in the place of that will be your R equals to A. So A1 will be I, 1 into I, 2 into J, 2J, plus 3 into K, 3K, plus lambda, give a lambda, and then give this 3i plus 2j minus 2k. So that will be in the vector form. So now we will see the second form, equation of the line passing through two given points. So let's say we have 2 points A in the form of vectors A and B vectors. So if a line is passing through vector A and B, then what will be the equation? So for that, the vector form will be R equals to A, vector A plus lambda into vector B minus vector A. So this form is the vector form. Now I'll tell you how it will be the Cartesian form. So let's say we have A as x1i plus y1j plus z1k, and B is as x2i plus y2j plus z2k. So in that case you can write this thing as R equals to x1i plus y1j plus z1k plus lambda into b2 minus b1 will give you x2 minus x1i plus y2 minus y1j plus z2 minus z1k. So you'll get this. So here you know that R can be written as xi plus yj plus zk. So here if you find, so you will get just x minus, okay, I'll write it for you. So x1i so here we have xi plus yj plus zk is all equals to the same thing that is in the right side. Just lambda into this. Plus z2 minus z1k. So all this we have. So what we will do here, we will simply take this x minus x1 like we did in the previous form. So we will just take this x1 minus x minus x1 here divided by x2 minus x1. So simply just you can say it will be x minus x1 divided by x2 minus x1 will be same as y minus y1 divided by y2 minus y1 equals to z minus z1 divided by z2 minus z1, and that will be equals to the lambda, and that is only the Cartesian form. And it's very simple as well. If you want to find out, let's say we have a as x1 y1 z1 with the coordinates this, and b is having x2 y2 and z2, then finding the Cartesian form is very easy. Just write x minus the coordinates of a is x1, then in the denominator you just have to subtract this x1 with x2 with x1, so this, and then y minus y1 divided by y2 minus y1 equals to z minus z1 divided by y2 minus y1, and here it will be z2 minus z1. So that's it. So let's see example. We have these points, so we have to find the vector and the Cartesian form. So vector form will be r equals to a, so that will be 3i minus 2j minus 5k, so that will give you a plus lambda into b minus a. So here finding this one, you'll get 3 minus 3i plus minus 2 minus plus 2j plus 6 minus 5 will give you plus 5k. So that's it. That will give you the vector form. So I will be plus 3i minus 2j minus 5k plus lambda into 0i, not writing that, so 0j as well, and then 11k. So that will be the answer for this question. This is the vector form. And then Cartesian form. So we have already calculated this one. So Cartesian form will be x minus 3 divided by 0, y. So that will be y, and this 2 will go there. So y plus 2 divided by 0 equals to y plus 5 divided by 11. So that will be the Cartesian form.